We use AI every day, from voice assistants to Netflix recommendation. But what if AI could actually think, reason, and learn like humans? How close are we to that reality? That's what we are going to be talking about today. Welcome, everyone. This is another session of the Tech Social that we normally do on Thursdays. Thanks a lot for being here. My name is Gabi. I'm a business analyst at Cogent. I have Edgar with us, who is always our moderator. And today we have two speakers. We have Koerner and Paul. They will have a chance to introduce themselves in a bit. And today's topic, as I was saying, is the story of LLMs, agents, and AI futures in our lives. If you have any questions, if you have any comment, you can leave them on the chat. You can raise your hand. We will take them. And thanks again for being here. And then Edgar, over to you.
Thank you, Gabi. Yes, so I'm really excited about today's episode, right? And in particular, we started talking to Koerner, and he was telling us more about the kind of research that he's making, how he's exploring different areas in the AI space, right? And that basically takes us to any next steps that the AI can take, right, moving forward. So when I was talking to him and we hang up on that initial call, I immediately thought, I should invite Paul to this because I know that he's super passionate about AI, and he also has all of this experience already, on the SAP space and in general exploring and being curious about it. And I believe that's why we will have an amazing program today. So yeah, first of all, I'd like to start by having this introduction from our speakers, and we will take it from there, right? So in this case, I don't know who wants to start. Perhaps we can start with
Koerner, and
Koerner.
I'm at you.
Yes,
Sure.
amazing.
So I could talk a bit about my research experience. I'm Koerner. I'm a research assistant at Michigan, where I've been involved in several AI projects. When ChatGPT came out, I helped U of M build their native generative AI services. I've worked in a surgical robotics lab and more recently on some kind of data extraction AI projects for the School of Medicine. Last summer, I helped a Stanford startup build a kind of AI co-pilot for investment analysts at JP Morgan Chase and Goldman Sachs. So very interested in AI and kind of what the future holds and how businesses can take advantage of these changes.
So I'll jump in. My name's Paul Modderman. I actually have two jobs right now. One job is I'm SAP AI director at Mindset Consulting, where we take features both of SAP Business AI or other AI platforms, and we apply them to our customers' use cases in SAP. So they will often have a business need that can be addressed with either some feature of generative AI or some feature of just your standard like ML predictions, classification, that kind of stuff. And we apply it to the applications that they do in their business. But I also have another job that I just started this week. I'm a founding engineer at Nova Software, which is a Silicon Valley based startup in the AI plus SAP space. And we are working on agents, very, very highly complex agents that modernize the SAP software stack. So if you imagine the giant piles of old code in your SAP ECC systems or other, older versions of ERP, and you're wanting to make the jump to S/4HANA with a clean core, we are creating agents that literally look at the old code and create clean core compliant versions of that code much, much faster than your normal service provider or SI or whatever would handwrite those replacements. And it's incredible. I'm deeply honored to be working with people from Google DeepMind, Facebook AI research. I work with MIT graduates. I work with Caltech graduates. I work with Berkeley graduates. I'm surrounded by all these amazing people in this domain, and I love the opportunity to bring goodness from mindset to Nova and goodness from Nova to mindset in both of those things. So, God, I feel like I'm gonna go on forever. I apologize. I just went back and looked at this. My first AI plus SAP blog I wrote in 2015 on the Mindset website. In 2019, I wrote an O'Reilly book, Practical Data Science with SAP, about using machine learning and things like that with SAP data. And then about a year and a half ago, I started actually working on a project applying generative AI tools to SAP transformation stuff. And I can talk about some of that, although I can't name the customer, I can't name specifics, but I can talk about a lot of that stuff. I feel like I'm jabbering. I'm too excited to like say so many things, but Edgar, Gabby, Koerner, I'm so glad to be here. Thanks for having me on, guys.
Fantastic, Paul, and congratulations on that new position. It sounds really, really exciting,
It's
right?
super exciting, yeah.
And especially precisely because you get this opportunity to work not only with the practical side, but also with people who are on the research side, right?
Very cutting edge,
And
yeah.
yeah, exactly. And on that note, of course, there are two things that I would like to start speaking about, right? The first one is about agents in agentic AI, right? Sometimes whenever we are talking about it, I think there's like a difference between, you know, some kind of workflow that is kind of predefined, and then that it gets added some AI into it, right? So there might be something about that. And then what it's really the actual thing, right? That is, in theory, that these agents are able to find like their own way into finding a solution. So that's one space that I would like to explore. And especially because based on what I've seen, and I haven't seen that much, right? But what I've seen is that at some point, if we let these agents run, right, they find ways to solve things. But then again, I'm thinking about consistency a little bit, right? What happens if they find, like, say, the right way, and at one point, this same agent with this same task, they find a different way and then deviate from the result. So that kind of, let's say, question is there for me, like, how is that really happening in the real world? And at the same time, let me connect that with what Koerner is doing, right? That he mentioned in his profile, and by the time that we were talking about three particular fields, that is category theoric AI, neuro-symbolic AI, and neuromorphic AI, right? And how can these fields help us in those kind of problems, basically, right? So I don't know, maybe Koerner, if you can tell us a bit more about these particular topics, and how do you envision this joining, right, the current wave of AI and LLMs, and then we can hear Paul about his experience and how that is really fitting in the real world, right?
Sure. So let me kind of start out by mapping the territory out a bit and just talking about what an LLM is and how it works. So the details of LLMs and their implementation can get very complex, but at kind of a high level, the way that the machine works is fairly simple. It's basically setting up a calculation that answers the question, if I, based on the information I was fed in my training period, when I am given a new input, what is the most likely continuation of that input? So the first LLMs are just predicting the next token or the next word to come word by word until they find a stopping token. So the whole paradigm is a statistical paradigm. So what LLMs are doing is they're giving you the most plausible continuation of your question based on the entire internet. And if you feed a machine the entire internet, it turns out it learns very general patterns common to human language that allows it to use language. So here we kind of run into a problem already where the LLM is giving you the most plausible answer and not necessarily a rigidly correct answer. Nevertheless, it's amazing how much of human intelligence and productivity can be modeled by just predicting what the most likely continuation of text is. But I think that statistical nature speaks to some of the kind of current limitations of LLMs and agentic technology. An agent is just when we give an LLM agency over other computational processes. So we can imagine like a web browser, you can use the browser interface and click through, different features of that with your mouse, or you can write a computer program that does the same thing. So the LLM just provides the kind of brain or control mechanism for controlling that agentic flow. Um, so, like I said, this is great, and it can do things that weren't possible 5 to 10 years ago, but it still does have problems with what we call hallucinations or inaccuracies or biases. I think, on a 5 to 10 year horizon, that's really only going to improve even without substantial theoretical innovations. I think the current transformer architecture that's so popular and responsible for GPT, DeepSeek, and Llama is even with further scaling can probably take us, to very, above human level accuracy. And there are ways that we can move beyond this inherently statistical paradigm by incorporating more symbolic features. So right now, a neural network doesn't have any kind of symbolic layer for reasoning. It's just operating statistically. And there's a field of artificial intelligence research called neurosymbolic integration, where researchers think about, okay, what are the optimal ways to integrate connectionist statistical neural networks with symbolic computing that has hard rules of propositional logic and kind of discrete structures of reasoning, which actually was responsible for kind of the first wave of AI in the 50s and 60s in the kind of post-war boom of research into AI and computation and decision theory. So that's kind of an overview of maybe how the technologies work and where research might be headed as far as improving some of the inherent problems with accuracy.
Mhm.
Yeah.
Wow, that's amazing. Yes, Paul.
Yeah. So, Koerner, thank you for that stuff too, because I've been Edgar. I was doing my own like mental continuation of what you were
Hmm.
saying in teeing up the question, right? And
Hmm.
one of the things you mentioned, I think, was a great point about this agent stuff. Was there's a distinction between like a workflow, like a where like there's a step, a step, a step, a step, and maybe there's an AI or LLM at some of these steps, like performing a very discrete task of something, and then there's like that's sort of one layer, but there's a newer layer emerging more and more, and there's a great post, and Edgar, you probably saw this by Anthropic about the state of agents today. The 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 real agentic stuff, I think, is at that layer above or below, depending on which direction you think in, of that
Hmm.
workflow, where rather than following a workflow, an LLM or a crew of LLMs is kind of literally creating the workflow itself, right? The
Hmm.
LLMs, all you do is you say, here are the tools in front of you. Here is your task. Decide which tools help you do the task and keep going until you think you're done. Right? That
Hmm. Hmm.
is that is amazing. But I mean, to you guys' points too, like the either inaccuracies or hallucinations are they're a tripwire in that process, right? Because let's just imagine that a language model has a 90% positive rate on doing kind of exactly what you want it to do or what it wants itself to do. If you think of a potential flow as having 10 steps in it, by the time you reach the 10th step, if every step has a 10% chance of not doing what you want, you're down to like a 33% chance of that whole thing collapsing when the LLM tries it, right? So
Mhm.
every step in the process, whether it's scaling the traditional GPT style things or it's some other things like the newer scaling the inference time stuff, like everything that increases that likelihood of the LLM doing something right increases the likelihood of the whole chain happening right. Right. So even if you look at
Mhm.
if you read I mean, OpenAI doesn't produce like deep papers about what they do, but they do publish some of their benchmarks and stuff like that when they release a new model. And even just the larger scale of GPT 4.5 has reduced that hallucination rate of its outputs. And so you can imagine that even just sticking in a new LLM into your agent flow will kind of give a little boost to the possible success rate of your agentic tasks. And there's a lot of things too where not just uh, increasing the accuracy of the LLM, but also and this is something that's fascinating that I've seen is that like getting really smart on how you get the LLMs to review themselves along the way, having like review steps in the process of that stuff. It's kind of
Mhm.
surprising how good they are at like critiquing themselves, right?
Mhm.
Here's an output from Claude, and then have Claude look at the output and go, oh no, that wasn't right. You should do this and this. That's surprisingly good. It surprisingly helps the agent chain happen like that. It's kind of amazing, and it's how a lot of the best either code writer or other agents do it is like that reflection layer of, okay, I was going to do that, but does that look crazy to you guys? Like that kind of a thing
Mhm.
is what's happening below the covers of a lot of this stuff. So
Mhm.
I feel
Mhm.
like I've been talking forever. I've like wandered off the
Oh,
course of where you
definitely.
were going, but those are my thoughts on
Mhm.
agents these days, Edgar.
Mhm.
I hope that helps the discussion.
Yeah, yeah, definitely. I think that's super interesting, and I think it matches what we were talking or what Koerner was saying before, right? To me, it has to do with this perhaps shift, if we want to say it that way.
Yeah,
And these days, it's like one day after the other, we are shifting here and there.
yeah.
But for example, that part of grounding these models, right? Particularly with this symbolic approach, meaning that we are kind of generating some relationships that we can kind of give to the model as an explanation. And that's how I understand this neuro symbolic AI, right?
Hmm.
That sounds to me also like these hierarchical databases, right? To ground the models, where we are not only giving pieces of information, but actually trying to create some logic between these symbols that these models can use later, right? To be more accurate. And I believe that that game, right, that, as you were saying, Paul, of trying to get more accurate as it progresses in actually executing tasks, that whomever who managed to find a good way to do that, right, it's going to be way ahead in the game because in the end, for enterprise applications, we need precision, right?
Yeah.
And we don't want to see, you know, accounts coming with information that is not really matching what they should match. Then we get an audit, right? And it's like, oh my God, this is an AI's fault. But then what, right?
Yeah,
Who's gonna
that's
take the blame for that?
like if I can climb on a soapbox for a second here and say something too, is that like I'm almost disappointed, almost disappointed by like the enterprise folk. I mean, I get it. I understand businesses have to do what they do, but I'm almost disappointed by the enterprise focus on like you must do this, and we need A and then B and then C. Because one of the great things that I personally find useful with like modern AI is like creative expression, right? I don't want an
Mhm.
AI to like be my voice, but I do want an AI to help me find my voice and help me brainstorm things and help me discover like new weird little ideas. And like a lot of the action now in like the enterprise world for this stuff is finding the repeatable, dependable use cases for that stuff, and that works. There's tons of stuff you can do. But I often say just give people education and examples and then give them ChatGPT and let them figure out for themselves what they want to do. And it will blow your mind. I've done a few like prompt engineering classes and things like that with folks who are new to it. And it blows my mind when they come back to the next session and they're like, you know what I tried? I tried this and it worked and it helped me. And like the thing that they tried, like I as an AI nerd, I could never have thought of like what they might need to do. But just give them the tool and say, here's an ocean, swim if you want to, right? Like that's so powerful for people that I think enterprises are kind of underestimating. Just just give people the tool and let them figure out how to make it better for themselves.
Yeah, I think something very interesting in what Paul is saying is how useful it is for kind of any kind of field. As a research assistant, building AI tools, I often use AI as a
Yeah.
kind of conversational partner in
Yep.
making decisions about how to implement those AI tools. But there was something earlier you're saying, Paul, that I thought was very interesting about reflection and how a lot of the new updates to AI that improve accuracy are really just computationally mimicking the way that human beings solve problems.
Yeah.
Like we have chain of thought where you're kind
Yeah.
of breaking things down into mechanical steps, and you have reflection where you're kind of engaging in self-doubt or self-critique. And I think there's a lot of room for more kind of exploits like that that mimic human cognitive processes. Particularly at inference time. You talked about
Yeah.
scaling inference, and I think we're going to see a lot more there. We've seen a bit already with O1 and DeepSeek. And I'd be curious to hear your thoughts, Paul, on DeepSeek, on kind of test time compute and what maybe new possibilities are available for enterprise, given that the model is totally open source there.
So I'll tell you this with things of the nature of DeepSeek or O1 or O3 of that, I mean if you think about the uh Daniel Kahneman System 1 System 2 type thinking, Thinking Fast and Slow, great book, everybody go read that book. um the A lot of times, so I when I go show people kind of what can be done, there's like two classes of responses that are like outside the boundaries but are interesting. So some people ask about things that are like, oh yeah, if you just do this, you're totally good. But then there are two classes of stuff that are outside those things. One class of thing that people ask about is they'll say, I'll show them something, or we'll do like a lunch and learn or whatever, and they'll say, oh Paul, but could AI do this? And then and I'm like, oh, you could have had that already. You didn't need AI to do that thing. Like like there's that class of response. But then the other class of response or idea is like a thing, kind of like what you're describing, Kerner, where like the ask of what they want is like outside the bounds of like a fixed compute model, where like your ChatGPT 4.0 or 4.5, which is like just blast forward, constant compute per token, you're done. That like a lot of places, especially enterprises, like they want help with planning things. They want help with, really complicated scenarios. And I mean, if you imagine, supply chain scenarios or planning for complicated work processes, like it may not be the case yet that you can just give a one pro like here's my document, plan my entire business for the year, right? But if you start to break that down into like areas and sections, and then you break it down into like the tools that an LLM might need to help it do the things you're asking it to do, like I think every week more and more things are possible in the planning scenario um action task world where like I've even seen there was an interesting Andrew Ng has this great company called deeplearning.ai, and they invite lots of people from the startups on there to give demos of the tools that they're making. And somebody from OpenAI came on and did like a short like 2 or 3 hour lessons on using O1. That at that point O1 was the latest frontier of the reasoning stuff. Uh, and one of the great examples was using O1 to create a plan for something and then using a more traditional fixed compute LLM like 4.0 or whatever to execute the steps that the plan wrote out. And I think that's really, really new and really probably underappreciated at the moment of the capabilities of something like that to accomplish don't just do this one thing, but think through a chain of things and then write a plan to do that chain of things and the plan has been reflected on and tested in the AI's own head, so to speak, right? Before the plan is out there. I think that's coming super fast, super, super fast for people looking for those scenarios.
Yeah, I think one quick way to kind of improve how you interact with AI technology is just understanding that even with billions of parameters, there's only so much a model can accomplish in one prompt. And
Mm.
often people will ask the model to do something that could be accomplished by splitting up the task into like a dozen prompts, but they complain that the technology doesn't work because of the way in which they're interacting
Mhm.
with it and not kind of splitting that up.
Oh my gosh, that's such a great point, Kerner, too, because I think a lot of so I when I show like developers who haven't been using these tools, their kind of first pass at this, they look at like a chat prompt and they think of a command prompt, right?
Mhm.
So what they want is like, tell me exactly what to type to get exactly what I want. And like you have to help people break that idea of like, no, but that's not what we have here. We have a thing to help you think about this, not just like dir/p or whatever or pwd or whatever your like Linux command line stuff might be. It's like ask it to help you think through the thing. Okay, I'm so sorry I'm talking so much, guys, but there was when I first helped somebody implement like a chatbot for their company. I had access to the logs, and we would like review people would complain about something, we'd review the logs or whatever. And there was one person who every morning, for some strange reason, all this person would do was they would take a SQL statement from the code they're writing and no prompt around it, nothing. They would just prompt the LLM with that SQL statement. And then the ChatGPT would be like, I don't know, what are you trying to do? I can't help you with that. And then that person would just dip out and be done. But then the next morning they would do the same thing. And I was like, buddy, what are you trying to do here? Like, clearly there's a mismatch of like expectations versus capabilities here, right? And that's, I think, like the key to unlocking this for like general purpose is like setting the expectations right on what's going on for this stuff.
Mhm. Mhm. Okay, so I leave one point here, one question, and then Paul, I'll let you drive it home, right?
Yeah, yeah,
I mean, like the show.
yeah,
But then, if I'm hearing correctly, we are talking about this coordination, right, between, and I think that's a lot there out there, like coordinating humans and like kind of giving that particular idea to LLM and now to the agents, but in the end, pushing this reasoning from a human to the AI. But at
yeah,
the same time, we're also talking about the AI taking new shape, right? And perhaps with this reasoning or advanced reasoning capabilities, being able to establish that course of action. So
yeah.
my point is, or what I would like Koerner to tell us more about is, what are the possibilities for these new ways of creating AI to actually kind of be there in the middle and be, reasoning more to create these kind of workflows that are even more powerful than what we have today, right?
Well, I think it's important, at least for now, that there is still a human kind of having some high level control of the processes that the AI is involved in, whether that's like having some scaffolding of what the workflow is. I think, there are a lot of risks from AI, both, at an enterprise level, you could possibly lose money if your technology isn't configured
Yeah.
correctly. At kind of a more global level, a lot of AI researchers see a kind of like runaway AI explosion, or super intelligence or AGI as something that could be very threatening. That's a whole other conversation. But I think having some level of human input or control over the workflow is important now, at least.
Mhm.
Yeah.
Okay. What what do you think, Paul?
Yeah, I think the only thing I would say about this too is like, first of all, fully agree with Kerner's position there. The other thing is that like what LLMs, whether it's traditional or inference scaled, still lack is like you could have all the IQ points in the world, right? But what we still have at the moment, anyway, at the moment, what we still have is like volition and like the desire to do something, right? If an LLM isn't responding to a prompt, it's not doing anything. It's like there's the GPUs are just silent, right? They're not doing thinking. They're not like trying to accomplish something new. And that's a at the moment that's where we get to have the most fun is like setting the direction of something and then getting a pile of GPUs and transformers and blasting matrices through them all there to get you to where you want to go with that stuff. And I think that's really powerful. But Kerner, now that Edward is gone and I can talk to you about what I really want to talk about. No, I'm kidding. But I do want to hear about the perspective in academia, like the folks that you work with in your research, or just the people around you, like what are their attitudes about using this technology to help them do things? How are people responding to it in that world?
Yeah, I mean, I think there's a lot of optimism, definitely, and there's also a certain amount of caution. I mean, I think
Mm,
people can see the tremendous utility of LLMs, and if you extend the clock out 10, 20 years, like the possibility for further agentic AI that is embodied in robots, or
right.
other devices that human beings can interact with. Um, so, like in the hospital, for example, they're working on using LLMs to extract data from medical reports so that
Mm,
clinicians or data analysts don't have to spend man hours doing that. They're working on AIs to actually evaluate medical student performance on simulated patient exams. So you
mm,
set up a
mm,
network where you have like the speech vector and the transcript, and you do cross attention on that,
yep.
and then feed that to fine tune an LLM to give you
Mm,
a score. So, I mean, there's a sense that, yeah, this will have tremendous utility and probably change a lot of aspects of daily life going forward. Maybe not in there will probably continue to be a kind of boom and bust cycle, but I think
sure.
the long-term prognosis, people are very optimistic. And I mentioned the kind of AI risk perspective, which I
Hmm.
think is mostly a very academic one.
Hmm.
And I think it's not unreasonable to, I mean, like fire, any kind of thing that is powerful can be used for good or evil,
Hmm.
it can warm your house or burn it down. So I think it's good that people are aware of that perspective. However, as like an AI practitioner, I'm sure you know that like these systems as they are right now are incredibly brittle. They're
Yeah.
in some ways like a little stupid. Like there's some
Yeah.
things, it's amazing because they can do kind of PhD level research in virtually any field, but they can't like count two sets of numbers
Yeah.
together correctly. Like, so I mean, it's amazing to me. To me, it's like a new form of life or intelligence that
Yeah.
to interact with. And it has, like I said, this, combination of strengths and weaknesses where it can do
Hmm.
things humans can't do. But then there are also things humans can do very easily that it can't really do either yet.
Yeah. In the world outside of research, in the business world, and I work a lot and talk a lot with software developers who are in the space that I'm in enterprise software development. They're especially in the SAP space, I think the population skews a bit, and this is not pejoratively, I'm just stating the population skews a little bit older and a little bit more conservative. And I don't mean that politically, I mean that personality wise, right? Um, where there is still a lot of like, yeah, but what can it do for me kind of like feeling out there that I think is both. I take two perspectives on that. I take one perspective I take is like, come on, just try it. But the other perspective I take is like, well, yeah, like I still bump up against things that I'm like, oh, but just like, why aren't you getting what I'm trying to get you to do, right? There's still brittleness, there's still gaps, there's still like communication barriers or whatever that we experience with that stuff that the maybe the naysayers are like just they're putting their whole hand on the scale on that side,
Totally. Totally.
right? Yeah. So and that's again like eh, I sound like I'm kind of hating on the naysayers and I'm not because they play an important role in like sharpening things up and helping to improve what the things are. But I myself am definitely not a naysayer. I'm a Kool-Aid drinker 100% here in this realm. So I am curious about because I think you mentioned some robotics stuff too, right? Tell me more about the robotics stuff you've played around in this space.
Yeah, so I worked at Michigan's Image Guided Robotics Lab, which is headed by Dr. Mark Dralos. He did like a electrical engineering master's and then
Mm,
med school and a surgery residency. So he's very well equipped to work on surgical robotics projects.
uh-huh.
So I could kind of nerd out about the details for too long, but basically, the idea is to build robots for automated surgery. Right
Mm,
now, he was an ophthalmologist by training, so he started out with trying to automate simple ophthalmological procedures. I essentially worked on training a neural network that did the path planning for the robot. And the robot is a UR5E electromechanical arm, and it has a laser on the end that can perform a kind of laser interferometry-based scanning called optical coherence tomography. It works a lot
mm.
like LiDAR, but you can get a 3D map of whatever you're imaging.
Okay.
So I essentially made the brain of that. But the PI thinks that there's it's very hard to train a surgeon. It takes incredible resources,
Yeah.
time, and what this means is that medical care is a scarce resource. So there's surgical procedures that don't happen because of insurance reasons, because of a lack of surgeons. So if we can automate surgical procedures, we can, extend care to as many people who need surgeries. We can send it to developing countries where there aren't as many trained surgeons.
Yeah. Yeah.
We're also, NASA is considering funding the lab because, they don't want to send a whole surgeon and train them as an
Yeah.
astronaut to Mars. It would be great if we could have a kind of device
Oh.
handle like an appendectomy if an astronaut appendix is shot during a mission to Mars. Like what do you do if you don't have some little robot tool that can perform that for you? So that's it's a growing field, and that's maybe like a 10-year vision maybe for what the
Mhm.
technologies could look like. But there's in medical robots, they have the same kind of levels of autonomy that they do in the self-driving car field, where
Mhm.
you have like assistance all the way up to full automation. And
Yeah.
right now, almost all of the technologies are very much within the kind of assistive paradigm. And there are very few, only for like some very simple, like biopsy procedures where the intervention is totally robotically automated. But I think pushing that boundary in the same way that self-driving cars have pushed how much autonomy is acceptable in a technology is likely what's going to happen in the coming years and decades.
there's something magic about like the difference between hearing about autonomous whatever and experiencing autonomous whatever is like it's like flying across the Grand Canyon in terms of like where you go from one to the other. So I was in San Francisco a few weeks ago and I got my first chance to ride a Waymo.
Yeah.
And like prior to that, I was like, "Oh, that's really cool. I hope someday I get to ride one." And then I got in one and I sat in the passenger side and I was looking at the little screen where it shows the lidar that's like it sees things and it sees like a surprising amount of detail and things. And I went from, gosh, I wonder how this is to like I would take this every day, everywhere. Like, give me, if I got rich, the first thing I do is be like, just let me buy a Waymo from Waymo as my personal driver. Just give me that. That's all I want. That'd be great. I don't want a private jet. I want a Waymo. 100% that. And that experience pushes you from, oh man, that's really cool, to like, oh yeah, no, it's right in front of us. It's tangible. It's like, let's go. Let's do it. Gabby, uh, I don't know the usual protocol here. I see that we have a lot of people in the thing here. Do we take questions or comments if people want to do that, or do we stick to? I'm sorry, I'm breaking protocol here probably to ask you that, but do we take
Okay.
questions or comments if people want to do that?
We do, if they
Okay,
want to, they can raise their hand or put it on the
okay.
chat. Yeah.
Okay. So for everybody listening, if you want to drop a question in the chat or raise your hands or whatever, and jump in, and we'd love to talk with you guys too. But okay, back to the fun stuff. Kerner, t give me your because I have something in my head, but give me your like aha moment from going from like, hey, what is this to like, oh, this is interesting in terms of LLMs. Like, what was that moment for you?
Yeah, it was really when ChatGPT came out and I first tried it. And I mean, I would spend, I'm a little embarrassed to admit, but I would spend hours interacting with it. And, because with humans, their knowledge is generally very siloed. But when you
Mm,
train on the entirety of the internet, I mean, it can talk about pretty much anything that human beings can talk about and can
yeah,
do so at a pretty high level. Obviously with the limitations we've kind of mentioned, but those seem to be disappearing by the day. I personally really like Anthropic's LLMs.
yeah,
I use Claude a lot. I think at least last time I've checked, I find its responses are generally a bit more helpful than GPT, though, this field is just changing. So
yeah,
every day, there's news and like especially with the DeepSeek upset, I think more kind of a faster kind of accelerating rate of development is likely.
yeah. For me, because I had been I'd been following OpenAI's work in the GPT world before ChatGPT emerged, and for a while there was a playground where you could just use the API. Just the not it wasn't even like instructed. It was just continuations, right? And even then, I would just put in things like the first moment for me that I was like, oh, this is something interesting. Is I took a poem by E. Cummings and I put it in the little playground for GPT. I don't know, it must have been the Da Vinci version of 3, or maybe even, I don't know if 2 was available as an API, but anyway, I put that in there and like it gave me back because it's a relatively the poem I used. It's called "I Shall Imagine" by E. Cummings. It's a relatively short poem. I put it in there and I didn't say anything. I just put the poem in there, and like that LLM went on to do completions of that poem, like more verses that were like if I wasn't knowing that I was looking at like GPUs blasting matrices through themselves, I would have been like, "Oh, interesting. That's an interesting direction that poetry took." Right? It was not obviously bad in any way. And for me, that moment of like, oh, was like that was the eye-opening awakening moment for me of like, let's keep going with this. This is something interesting. Throw more money at this, throw more power at this, whatever. And let's see what happens. And then, from that point on, I have spent way too much money staying at the forefront of stuff, right? I admit I'm a Chat GPT Pro subscriber. I shell out the $200 a month for operator and for, all that for O1 Pro and all that kind of stuff. And like I just want to feel the future in my hands when I do that stuff, right? It's that I just feel like it's kind of like you said before, like there's it's like maybe possibly witnessing the gestation and birth of a new kind of intelligence altogether. And that's how could you not be fascinated by that? I don't understand. Everybody on this call who is not fascinated by this, there's something wrong with you. It's so clearly fascinating that how can you not I literally go to sleep at night just kind of thinking about like, God, what if it was blah, blah, blah. Like that is just running in my head all day long.
Yeah, I mean, it's interesting you talked about GPT-2. I remember the GPT-2 playground, and being totally honest, I was a little dismissive of the technology at that point
Uh,
because it felt a bit more like autocomplete on your phone where it could generate text, but there wasn't as much kind of coherency or
right.
semantic stability in the text. But this speaks again to like learning how to use the technology best because I wanted to use it as chat completion and you were using
Yeah.
it as more direct just completion of text and found like a lot of utility in that. And if I had had that mindset of knowing how to interact with this technology when it was at that more raw stage, maybe I would have been able to see, okay, this may be very limited now, but the direction it's going is really incredible. And I think that sense of wonder, I definitely connect with that. I think we're still at the very early stages of the
So early.
technology,
Oh
which
my
is
God.
incredible to think. It's made this huge impact in the economy in like the last 2, 3 years. And this is really only the beginning. Like, I do think we're going to hit a point of kind of super intelligence or AIs that can perform better than humans, that can come up with new scientific discoveries and emulate forms of human creativity, like scientific creativity, that are very hard to mechanically emulate.
Mhm.
I think that's almost, maybe it sounds too optimistic, but almost inevitable
Yeah.
given,
Yeah.
the present trends.
Dario Dario Amodei, the CEO of Anthropic, who makes, I mean, you know this, but they make Claude, which is both you and I think it's my favorite vibes chatbot for sure. Um, he's written a couple of essays on his personal website that I find prescient and so well said that I just keep quoting that company and him. And he sort of eschews this notion of like AGI and ASI in favor of a term uh, called powerful AI, which I think is an amazing framing of that stuff in the sense of like it's hard to draw a line in the sand of like, okay, if you're on this side of the line, you're nothing. You're a worthless intelligence that means nothing. But as soon as you cross this line, oh my gosh, you are worthy of our attention, of our love, or whatever, right? And like, there's no clear division between that stuff. And what powerful AI means is that as as the different companies and different frontier models like you know, simultaneously cross and not cross that fuzzy, undefined line, like the powers and capabilities don't don't fit into like a neatly contained single eval box that this stuff can capture. And so like powerful AI just means it has the power to do many, many things that you would want it to do in interesting ways that you maybe couldn't even do yourself. And that help like I feel lucky to be alive right now and be watching it, and especially extremely lucky to be professionally engaged with this stuff because it's like the universe is shifting under my feet, and at least I can ride the beast while it's rideable. You know what I mean? I don't know.
Yeah, I think that's a great approach to take. You know, with any kind of like big societal change, there will be great things it does and things that aren't as great as that it does. And I think being able to harness it and kind of ride the wave is a great goal.
Yeah.
What you were talking earlier about kind of evaluation and what is the kind of end state that this process is moving towards. I think arguably, you know, where humans like to think in terms of very discrete conceptual categories and binaries, like we're at AI versus we're at AGI. I think with most things in reality, there's more continuity between things like you're talking
Yeah.
about not necessarily reaching a binary like, okay, we're at AGI or ASI. I
Mhm.
think arguably, Chat GPT, even GPT-3 shows an amount of general intelligence in AI. I think arguably, given that AIs can do some tasks as good as PhD level experts, how do you say that isn't, a form of kind of early nascent super intelligence?
Yeah.
It's hard to say.
Yeah.
But I think the idea of powerful AI, it's really only going to get more powerful. And I think, when we think of like AGI or ASI, there's almost a tendency to think like there will be one computation or kind of like one model. And I think the reality that we're moving toward is a multiplicity of models and different computations and maybe like higher level orchestrating control structures, but not a kind of single unified project.
Mm, mm.
Um, I have a question here, and I want Koerner to explain a little bit what neuromorphic AI is. And based on that, I have this question because I think it is known that LLMs are computationally expensive.
Mhm.
So how can neuromorphic AI address the energy and resource demands of like large scale AI models, making them like more accessible and sustainable? And also, if these neuromorphic chips are more efficient, could they replace the traditional computers in the future?
Yeah, that's a great question and gets to some topics that are very pertinent to robotics, especially. So, neuromorphic AI generally refers to AIs that are inspired by some dynamics from the human brain. So, one of the
Right.
more popular kind of paradigms for this is what are called spiking neural networks, where with like GPT, the representation of the neuron is just a number, just a real valued number. So there's not really much, it's not really trying to model a neuron in the human brain with any real level of accuracy. I mean, you could argue that the activation value is like the action potential of the neuron, but with neural processes, we need some temporal dimension. So rather than modeling neurons as just real numbers, for each neuron in a spiking neural network, we set up a differential equation that models an impulse response, like a little spike or click in a signal that looks, for all intents and purposes, the same way that an action potential firing in nervous tissue looks
Mm,
like,
mm.
neurons kind of
Mm.
click with their action potentials. So one of the great utilities of this is that, like neurons, neurons are at rest most of the time, and they only spike. They only have an electrical gradient ever so infrequently. So the advantage of that is that you need less power to represent the computations of the network because you only have to compute the spike once in a while, and the rest of the vectors are sparse. So you can have huge savings of power, and you can create neural networks that work on edge devices. So a robot can have a spiking neural network that acts as its brain or control mechanism or path planning mechanism, and it can work on like a Raspberry Pi or some kind of hardware that you don't need a massive GPU and like cooling system to manage the brain of the robot. People are always also thinking about modifying large language models to use spiking neural network architectures. So I think there is promising research there that might reduce the energy and computational demand of training large language models. It hasn't been adopted as the like primary paradigm yet. I think in part because like people show that the way we do it now like works and you can make a lot of money doing that. So there's
Yeah.
not as much incentive to, spiking neural networks are actually much harder to train because the optimization is it's easier to optimize a set of real just numbers in a grid versus optimizing separate differential equations for every grid cell. So that can get thorny. It's still an area of research that things are still being worked out very much, but it's very popular in robotics, especially, and I think it will hopefully be used to make LLMs less energy intensive.
Right. Great. All right, so we are almost there. Thank you, Koerner, for your answer. We're almost there in time. Do you have any closing comments, Paul and Koerner?
Uh, I,
Sorry,
I, oh,
I
oh,
missed you, Paul. This is Sridhar here. I'm a SAP consultant, so I'm just trying to understand. Joule AI, I know you are talking about planning. So, what other areas you are anticipating the AI will emerge in future in terms of SAP point of view?
yeah. So you hit on the planning one. That's of course, I think,
Mhm.
early stages, but it's gonna have a huge impact. The other one that I think the weird thing I think is that I think the SAP space
Mhm.
still drastically underutilizes what we might call the narrow or traditional machine learning and
Mhm.
prediction approaches for, I mean, there's so many ways because SAP software is really, I mean, it's obviously very business focused.
Yeah.
I think people like underestimate the value of simple things like prediction and classification in the business tasks that they do now. It like people treat SAP data like just forms over data
Mhm.
that I just need to record my transactions and then I'm done. Like there's so much unlockable value in the transactional data that is recorded in the SAP systems that just doesn't get analyzed. And so
Okay. Mhm.
I almost think there's like it's sort of a combination of like go back to the textbook and look at the old things plus I mean, I'm not an SAP salesman, so I won't make any money from this, but like
Mhm.
one of the reasons that DataSphere and then now the Business Data Cloud exist is because everyone's kind of waking up to the idea that like, yeah, all that data is more than just a pile of your sales orders. It
Mhm.
like it can tell you about the real reality of your business in ways that you just haven't invested in. So, and in fact, that's one of the reasons I wrote the book that I did with my friend Greg a few years ago, Practical Data Science with SAP, was that very idea of like, you're just not looking at the data you already have. Like,
Mhm.
start there. That's my cranky old man thought on that.
Okay. Okay. Got it.
Yeah.
What is the book you wrote? What is the book?
It's called, well, I don't know if I can put a link in the chat. I think the thing might close.
Uh-huh.
But
No, no, go ahead,
okay,
Paul.
I'll have to find it. So I'll talk while I do this. It's published in O'Reilly. It's called Practical Data Science with SAP.
Uh-huh. Okay.
Machine learning techniques for enterprise data. I didn't write the subtitle, so I don't know what the subtitle is. I had to go look it up here. But this is the book. I just put the link in the chat.
Okay.
And the
Okay.
idea there is like just take the data you have and like even one of the design approaches we used was like some of this stuff could be done on your laptop.
Okay.
It's like you just don't think to do this stuff because it's so outside the normal bounds. Just
Okay.
like look anyway, take a look at that. I would really appreciate that.
Okay, definitely. We'll look into that. And I'm looking for opportunities, meaning, since SAP is still in the old school, still not in the up to the mark like other software companies. But I'm just thinking, the opportunity point of view, can we develop ourselves since we already have Llama and DeepSeek, everything is now we can host in our server itself. Probably we can develop a product, and maybe that will enhance our skill as well. Also, we can bring it into SAP
Yeah.
AI
Yeah.
kind of thing.
Yeah.
What is your opinion on that? How
Yeah.
do you see that
So
as an
so with
opportunity?
the open models like the DeepSeeks and the Llamas and things like that, in terms of the SAP world, I think the cheater mode for that, the way to cheat that is just like start with ChatGPT channeled through Azure
Mm-hmm.
or Claude channeled through AWS Bedrock. Because I think there's a lot of misconceptions out there that like, oh, the LLMs will learn from your data. Well, if you use the services like Bedrock from AWS or Azure OpenAI, those vendors guarantee that they're not going to train the LLM on your data. So if you have an idea in your head that you want to test out,
Mm-hmm.
don't go buy a GPU. Just
Okay.
sign up for Azure OpenAI,
Uh-huh.
pay like just pennies to try
Okay.
out your prompts with your data
Okay.
and kind of go from there. Like that will be, and then once you validate that, hey, then maybe you can fine tune your own model on like your business scenario or whatever. But like start with the cheap way that's already guaranteed to not leak your data into the
Uh-huh.
world,
Oh,
right?
okay. So then Azure as a product. Okay. Okay.
Yeah, Azure.
Fair enough.
So the when you use like ChatGPT or whatever,
Mm-hmm.
Microsoft Azure has an enterprise shielded version of the API for that,
Okay.
so
Uh-huh.
they don't expose your data to the training of the models that way.
It's a good point, Paul. Yeah.
Yeah.
Yeah. Okay. Yeah. I think that's opens because I was thinking in that perspective how to develop a new product launching because we have to be in the first in the market. Otherwise, the
Yeah.
people will, obviously many people are. I attended a training and I also developed one of the AI myself
Hmm.
to run
Yeah.
within my. So I was curious how that runs, but yeah.
Yeah.
So, but it's a good point of working with Azure and see how that.
Yeah. Because
Okay.
I think that there's a temptation to be like, oh, I can host my own model and do all that stuff. But like the biggest problem is like validating your problem against
Hmm.
reality, right?
Okay.
And if you
Okay.
want to do that, it's cheaper to use
Hmm.
Bedrock or Azure or whatever to like test
Okay.
the problem against reality.
Okay. Okay. Okay.
All right.
All right.
Great
Perfect.
questions. Thank you, Sridhar.
Thank
Thank
you.
you so
No
much,
problem. Yeah.
Sridhar.
Thanks for having me.
All right. All right. Going back to you guys, any closing comments before we wrap this session up?
I'll let you have the last word. I guess all I have to say is I think from what I understand, the business community is pretty cautious about any kind of emerging technology, which is understandable. But I think there's now is the time to experiment and to be curious about what these things can do and to build infrastructure that you can exploit later when, say, GPT-5 comes out and, hallucinations are even less of a problem. You can make use of that infrastructure that you've built. So I would just encourage people to get curious about the technologies and experiment with them and not be kind of fear-based in approaching them.
That Kerner, what you just said it hooks into exactly my own closing thoughts, and this is a drum I beat all the time. What people need is education and examples. And once they see those things, they go nuts. They like follow their own trail to what they want to do. So if you're a dork like me or Kerner, show people what can be done. If you're a non-dork, look to your dorks to help you kind of learn it, but then like try it yourself and be expressive, be creative, use it to help you think outside the box. Closing statement. The defense rests, Your Honor.
That was amazing. Thank you so much, guys. Thank you, Koerner, and thank you, Paul, for leading this after Edgar left. It was amazing.
Yeah.
And then we'll be happy to have you back anytime for any other topic or just going back to this one. I'm sure there were a lot of things that we didn't ask today, and I'm sure Edgar will have a blast if you guys are back with him for a whole hour. So we'll keep in touch. Thanks again, and thank you, everyone. We'll meet again on another session. Have a good one. Bye-bye.
Thank you so
guys.
much.
It was nice. It was really very
Thank
good
you.
session. Yeah. Thank you.
Hey, all right. That was fun.
It was amazing. Thank you, Paul.